Year 13 revision, short revision video 19. So we have a question about the normal distribution here. So the time of the journey is represented by the distribution x, which is a normal distribution, and I always think it's useful to write down the key information we have. Mu equals 15, sigma squared equals 4. Remember, it's the variance that's given. And then sigma equals 2. It would be very easy to go wrong in a question like this, so understanding how a distribution is set up is really important. So over a long period of time, she notices that her journey takes less than 14 minutes on 7% of the journeys and more than 18 minutes on 31% of the journeys. Investigate whether the model is a good fit for the data. So remember that percentage, probability, proportion, they essentially mean the same thing. So we can convert these statements here into probability statements and work out whether the probabilities come to the correct values. So what I'm going to do is work out the probability of a journey taking less than 14 minutes, and I'm going to work out the probability of a journey taking more than 18 minutes as well. We can do this on the calculator. And I recommend that you do this in statistics mode on the calculator rather than run mode. You want to make sure that you go for distribution, which is F5, and then you need the normal distribution, which is F1, and then you want F2, which is the normal cumulative distribution. So data is set at variable. The lower value, well, we just need to keep a value that's as low as possible in order to get us full accuracy. So I'm going to go with just a negative 200. Upper value is 14, so we're essentially working out the probability of x being between minus 200 and 14, which will come out to the same value on the calculator as x being less than 14. Sigma is 2 and mu is 15. Make sure you enter the values in accurately. So this gives me a probability of 0.3085, or if I work that out as a percentage, there's 30.9%, which is not equivalent to 7%, and it's not close to 7%, which is the percentage of journeys that take less than 14 minutes. So this is already suggesting that this isn't a good model. We'll work out the probability of a journey taking more than 18 minutes. So we're using the same setup on the calculator, but this time the lower value is 18, and I'm going to make the upper value 200. It just needs to be large enough for us to get an accurate answer. So 0.06680 ... So if we convert this to a percentage for simplicity, that is 6.68%, which is not equivalent to 31%. So the model is not a good fit. And we do need to actually answer that and make it clear that we're stating the model is not a good fit. So, on to part 2. Cato believes that Kira's value for the variance is correct, but realises that the mean is not correct. Find to 2 significant figures the value of the mean that Kira should use in a refined model which does fit the data. So, what we're going to do is we're going to use the fact that x is a normal distribution with a mean of mu, which we now don't know because we're saying that the mean is not equal to 15, but the variance is correct, so we'll leave that value as 4 or 2 squared. Now, the probability that x is less than 14 is equal to 7%, or 0.07, or it should be if the distribution is correct. Now, we have an unknown value of our mean. If we ever have an unknown mean or an unknown standard deviation, or perhaps sometimes neither of them is known, we need to look at standardising to the z distribution. So this becomes the probability that z is less than 14 minus mu over 2, which equals 0.07. And we then need to use the inverse normal distribution here for the z distribution. Now, it can help to clarify this with a sketch. The the probability that z is less than 14 minus mu over 2 is 0.07. So what we're saying is there's a tail over here, which is a value 0.07, and this value on the horizontal axis is 14 minus mu over 2. So we need to use the inverse normal here. So we need to use the phi minus 1 calculation here of 0.07, and that's going to give us the value of 14 minus mu over 2. So on the calculator, this time we need to, in statistics mode, from distribution and normal, we need to pick the inverse normal, which is F3. So following the instructions as before, but we want the inverse normal. So the data is set at variable. The tail is the left-hand tail, and you can see it's on the left-hand side. The area is 0.07, and the sigma value, of course, we're working with the Z distribution now, which remember has a mean of 0 and a variance and standard deviation of 1, and that gives us minus 1.475791. So that tells me that 14 minus mu over 2 is equal to minus 1.475791, and I simply have to rearrange this equation to work out the value of mu. So this gives me 16.9515 ... So that gives us a value of mu equal to 17 to 2 significant figures, which is what the question gives us an indication that we need to work towards. It does say find correct 2 significant figures, the value of the mean that Kira should use in a refined model which does fit the data. So now Kira buys a new car. After driving to work to it in each day for several weeks, she randomly selects the journey times for n of these days. Her mean journey time for these n days is 16 minutes. So what is that telling us? It's telling us x bar is equal to 16, the sample mean. Using the refined model, she conducts a hypothesis test to see if her mean journey time has changed, and she finds that the result is significant at the 5% level. So if we were conducting a hypothesis test, we would say H0 mu is equal to 17, H1 mu is not equal to 17. It's a two-tailed test. I'm using 17 because the previous question told us we should work with the value of mu we found correct to 2 significant figures, so we want to work with mu equals 17. Now, the x distribution, the distribution of times, is normally distributed with a mean of 17 and a standard deviation which is equal to 2, so a variance of 2 squared. The x bar distribution, which is the distribution of the sample means, also has a mean of mu, but its variance is sigma squared over n. So its standard deviation is the square root of that, 2 over root n. So effectively, the standard deviation of the x bar distribution is unknown because we don't know the value of n, which is what we're trying to do. We're trying to find the smallest possible value of n. Now, the question tells us that the result is significant at the 5% level. Because this is a two-tailed test, are we working with the lower tail or the upper tail? How do we know? We compare the test statistic or the sample mean with the value of mu, and that tells us whether we're looking at the lower tail or the upper tail. So x bar is lower than mu because, of course, x bar is 16 and mu is 17. So this tells us that we only need investigate the lower tail. So because the result is significant, it tells us that the probability that x bar is smaller than the value of the test statistic, little x bar, that must be less than 2.5%. Why 2.5%? Because it's an overall 5% significance level, but remember we're working with a two-tailed test. So the probability that x bar is less than 16 must be lower than 0.025. Now, remember when I said that the standard deviation is unknown because of this factor of root n there? we have to convert this, we have to standardise to the z distribution because we don't have a known value of the standard deviation for the x bar distribution. So this becomes the probability that z is less than 16 minus the value of mu, which is 17, over the standard deviation of the x bar distribution, which is 2 over root n. And this probability is less than 0.025. Now, if I sketch that on a sketch of the z distribution, here's the mean of 0. Is a quick sketch. That means that what we're looking for is a region in the lower tail which is 0.025. Now this value here we need to find phi to the minus 1 of 0.025 for the z distribution. Now our value, which is here our standardized z value, can be less than this value because of course we want the probability to be less than 0.025. So our value could actually be on the left of this. So what we know is that 16 minus 17 over 2 over root n is less than the phi minus 1 value of 0.025. So simplifying this, that gives me negative 1 divided by 2 over root n must be less than minus 1.959964, which I've worked out using the inverse normal distribution in stats mode on the calculator. So now we need to solve this inequality. So I'm going to multiply both sides by 2 over root n. That's a standard deviation. It's always positive, so that's not going to have any effect on the inequality. But I'm also going to multiply both sides by negative 1 to get rid of the negatives, which will result in the inequality sign being reversed. So I have 1 is greater than 3.9119 ... over root n. Multiply both sides by root n, which is absolutely fine because root n is not a negative value, so there's no need to change the direction of the inequality sign. And then we're going to take the square of both sides, so n must be greater than 15.303 ... So that tells us that n must equal 16 as its minimum value.